When collecting data, we often do different types of studies. And in this lecture video, we're going to focus on studies having to deal with cause and effect. Let's start this conversation with kind of a silly example. Sam's conducting an experiment. He places an ice cube on the counter and keeps track of how much water is present as time passes. As you and I both know, if you place an ice cube on the counter, it's going to melt, and there will be more water as time goes by. Sam reaches the conclusion that the passing of time is causing the ice cube to melt. Let's think about that for a moment. Is time really what's causing the ice cube to melt? Just because the amount of water on the counter increased as time passed? Absolutely not. If that were the case, then the ice cubes that are currently in my freezer would also be melting as time passed. This is a classic example of the idea that correlation does not imply causation. There is a correlation between the amount of water on the counter and the amount of time that has passed, but that does not mean that time passing is causing the ice cube to melt. Just like the ice cube melting is not causing time to pass. What Sam was doing is an example of an observational study. That's a study where individuals are tracked for an extensive period of time to look for correlations between lifestyle factors, disease, and wellness factors. Correlation occurs when there's an observed relationship between the two events. When Sam looked at the amount of water and compared it to time passing, he found a very strong correlation. When we graph these types of relationships, a nice straight line like this implies a very strong correlation. But there's a difference between that correlation and an actual causation. Causation, or a cause and effect relationship, occurs when one event is the cause of the other. Often, there's what's called a confounding variable, which is an alternative possible cause for an observed effect, not the hypothetical cause. In Sam's example, he hypothesized that time was causing the ice to melt, but really there was a lurking variable or a confounding variable, which was, of course, temperature. The temperature on the counter was enough to cause the ice to melt as time passed. So while there was a correlation between the water on the counter and the amount of time passing, there was not causation. There was a confounding variable, an alternative cause of the ice melting. Another type of study is a clinical study, otherwise known as a clinical trial. This is a study intended to demonstrate that a specific treatment is effective in treating some disease or symptom. We call one of these studies a controlled study if the subjects are divided into treatment groups and control groups. That is, some people are given the treatment while others are not. This is best done when the two groups are comparable so that the end results can be compared. A controlled study is called a randomized controlled study if the assignment of the subjects to those treatment and control groups is done completely at random. You've likely heard of the word placebo. That's a fake treatment intended to make a subject believe that he or she is being treated. So in a controlled placebo study, we have individuals that are in the control group receiving a placebo rather than simply nothing. And since they believe they are being treated, even if they're not, this is called a blind study. It's a study in which the subjects do not know if they are getting the treatment or given a placebo. This can prevent the subjects from accidentally exaggerating the results. A double-blind study is a study in which neither the subjects nor the experimenters know who is getting the real treatment and who is getting the placebo. This prevents the experimenters from treating their subjects differently. Let's take a look at an example. The manufacturer of a new vitamin, we'll call it vitamin X, decides to sponsor a study to determine the vitamin's effectiveness in curing the common cold. 500 college students having a cold were recruited from the colleges in the San Diego area and were paid to participate as subjects in the study. The subjects were each given 2 tablets of vitamin X every day. And based on the information provided by the subjects themselves, 457 of those 500 subjects were cured of their colds within 3 days. The average number of days that a cold typically lasts is 4.87 days. As a result of this study, the manufacturer launched an advertising campaign based on the claim that vitamin X is more than 90% effective in curing the common cold. Let's break down the details of this study using the terms and definitions that we've already covered. First, let's talk about the target population for this study. The results of this study would apply to anyone that has a cold, ever. Let's compare this to the sampling frame. That's the population that this sample was pulled from, college students in the San Diego area. Now, looking at the target population and the sampling frame, we can see that these two are quite different. Obviously, the target population is a lot broader and more diversified than the sampling frame. They only looked at college students rather than a representation of the entire target population. The sample for this study is the 500 students that were already experiencing a cold. And since we're told that the subjects were each given 2 tablets per day, we can tell that this is not a controlled study. All of the subjects were given the treatment. There was not a control group to compare to the treatment group. Let's think about some potential problems that might show up with this study. One red flag that is often raised is the idea that the participants were paid to participate. This might encourage someone that really doesn't have a cold to suddenly feel a little under the weather. Another issue that we've already discussed is the idea that there's no control group or a group receiving a placebo to compare to. Also notice that the information that was used or the data that was collected was self-reported. The subjects got to report how they felt. Another way to think about this is that there's no measured data here. And the last potential issue that I'll point out is that the subjects were already having a cold when they were recruited. So when we're measuring the number of days that each subject's cold lasted, each subject may have started their treatment on a different day of their cold. Some may have already had their cold for a week, while others may have only had their cold for a day. Let's think about how we might improve this study. A better way to go about this might be to collect a random sample of people of all ages. We could put them into a control group and a treatment group and track their progress with measurable data, like taking their temp, their blood pressure, heart rate, and any other symptoms. Hopefully you can see the benefit of having a well-organized and intentional study. It gives us much more reliable results that can mean a lot more. And that will conclude this lecture video, where we focused on studies involving cause and effect.